In this video, we're going to be looking at sine and cos graphs. So this is when we want to graph functions such as fx is equal to sine x. So x is in the middle term, then we have sine and cos, or cos x. Then we can apply some transformations to make it a different equation. So the reason why we're looking at sine and cos in the same video is that the graphs look very similar and they have the same shape. Now, once you add some transformations to sine and cos, they do get quite complicated. Once you get an equation such as this, so negative x minus 3, and then a domain restriction, it can often be very hard to like plus 4, it can be hard to graph and then calculate questions for. So it's good you get a fundamental understanding of sine and cos graphs. So then once you add transformations and it looks a bit more beefy like this, you'll be able to break it down and you'll be able to look at the different characteristics and graph it. So beginning with, what does the actual sine graph look like? So this is what fx is equal to sine x looks like. However, it's actually a continual graph. So this is the shape, here you can see. So sinusoidal, and then it continues. So that's like a straight line, and then it repeats continually. As x goes to infinity, this shape continues, and then as x goes to negative infinity, it continues this shape here, and it just repeats that same pattern here. So between there and there, this same pattern is repeated over and over again. So why does it look like this? We'll bring it back to the unit circle. So we have the unit circle. We start to think, well, what happens when x is equal to 0? When x is equal to 0, we have this line here, and then obviously sine x, so that's like the y component, is equal to 0. Hence why we have this point here, 0, 0, and that's when we have sine 0, which is going to equal 0. Then as x increases, or the angle increases, because x represents the angle, it will keep on increasing and increasing and increasing until it reaches a maximum point here. So this point is a maximum, so that's when the angle is equal to 90 degrees, and typically this is to do with radians, so I refer to it as radians, so that's pi on 2. And at that maximum point, for the unit circle, that's when sine x is equal to 1. So that means this component here is going to be equal to 1. So the value there is going to be pi on 2, 1. So this value here, 1, is referred to as the magnitude or the amplitude. So the maximum value the sine x graph will ever go is, so that's the magnitude, and also referred to as the amplitude. And so it is equal to 1. However, once you do some transformations, it may increase or decrease. So just quickly, if we had an equation fx is equal to 2 sine x, then when sine x is, and then we sub in when x is equal to pi on 2, that is equal to 2 sine pi on 2, which is equal to 2 times 1, which will equal 2. So that means the magnitude is now 2. But we'll talk about that more in transformations. The main thing to know is that the height of the sine x graph, and it's a maximum height because the graph never changes from this shape, it just continues along, is referred to as the magnitude or the amplitude. And this same height will go down here, but it will be negative, which we'll talk about once we get to it on the unit circle. So we've reached this maximum point here. Then it starts to decrease. It's still positive, but sine x decreases until it reaches a point here. And that's when when the angle is equal to pi. So when you have sine pi, this is equal to 0, and that's when x is equal to pi. So here you have pi 0. So you can see there are going to be lots of x-intercepts. And when we looked at trigonometric equations, we saw that. When we had to solve for sine x is equal to 0, so we had sine x is equal to 0, then we realized, well, x can equal 0, or it can equal pi. But then it could also equal 2 pi, 3 pi, 4 pi, etc. So we had multiple different solutions when sine x is equal to 0, or sine x is equal to a different number. And when we work out the x-intercept, we're letting y equal 0. So if you let y equal 0, you're going, depending on what the equation is, or like not the equation will change, but no matter what the equation is, you're going to get multiple solutions. So going back to here, we have this point here, which is pi 0. Then it's going to start getting bigger again, but now it's going to be negative. So it's going to be increasing, but negative. So it's going to get more negative, 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 till it reaches a maximum negative point of -1, or the negative amplitude. That point here is going to be 3 pi on 2, -1. Then it will start to increase, or the magnitude will decrease, but it'll start to get less and less negative, till it once again reaches that point 0. That point 0 here. And that will occur at 2 pi 0. So you can see that the bottom half is equal to the top half, but it is negative. That's because in the first and second quadrant, sine is positive, and then in the third and fourth, it's negative. So you can see that shape here. So there's a specific name for one of these cycles, and that is called the period. So the period of the function is, for this one, would equal 2 pi. So that is how many sort of x values it takes to repeat one of these cycles. So you're going from 0 to 2 pi, and for this graph, that means it would go all the way up and down, and then across. Then at half a period, it will cross at the x-intercept, and then at quarter, we're going to have a maximum at each. So a period is not the distance between two x values, because the distance between two x values will just give you the top half or the bottom half. So the period is going to be double the distance between two x values. So the period is double distance between sort of like x-intercepts. So the difference between distance here is 0 to pi, so it's going to be pi. So then you double the distance, and we're going to get 2 pi. So looking at the cos graph now. So this is a graph of fx is equal to cos x. So once again, it's a continual graph where the shape continues along, the shape continues along there, and the shape looks basically exactly the same as the sine graph. However, the starting point is different. So if we get the unit circle, we can realize that the shape is going to be similar to the sine, because when we have a component, we have the cos and then we have the sine, and as we change angles, we can see that the cos and the sine are interrelated, and we could see that when we found out that when like sine 30 is equal to cos 60. So the shape is equal, but they're going to be equal at different points, and that's what we saw when we looked at trig earlier with the different functions. So beginning, when the angle is 0, so x is equal to 0, then the cos x is going to be at its maximum. So cos x is going to equal 1 when x is equal to 0. So that's why that point here is a maximum at 0, 1. Then it continues, but it gets smaller and smaller and smaller until it reaches a 0 point. So that point there is going to be 0 point at pi on 2, that point 0. Then we can find that point down there. So it's going to get smaller again. It's going to get bigger again until it reaches a maximum of -1 now though, because it's negative. So cos is negative in the second quadrant and the third quadrant, but positive in the first and the fourth. So hence why this was positive in the first, negative in the second, negative in the third, then positive again once in the fourth. So we have this point here, and this point is going to be pi -1. We're going to go up again, pi -1, and then we'll reach another point where it equals 0. So it becomes less negative. And this point here will be 3 pi on 2, 0. And you can see that when cos x is equal to 0, then sine x will equal its maximum. And that's because when looking at like cos 0 is equal to 1, and then sine 0 is equal to 0, and also for 90, so cos 90 is equal to 0, while sine 90 is equal to 1. So then we see this pattern, and then finally 2 pi reaches a point again when cos is max. 2 pi is 1. And you can talk about the same thing with the magnitude. So the magnitude for the cos graph is this value here, or this value here. And in this case, the magnitude is equal to 1, or the amplitude. So the period is the same thing. So you can talk about the period as from like how long it takes to get from that point to this point. But what a period is how long it takes from the graph at a certain point to come back to that original point, unless it's at the 0, and to do one cycle. So technically you don't have to start when x is equal to 0, you can start here. So we can go from here to here, and that can be one period. So moving this, we can see that along here, that is one period because we do one cycle. So that is a period, and that is also equal to 2 pi, as just before we sine. And you can see that because you're going to go down all the way along with the unit circle, back up again, and then it's going to repeat. So you can sort of think about the period as how long it takes for this unit circle to go around. Now it's not always 2 pi, because when you change the equation, let's say you have sine 2x, then when x is equal to pi, you're going to have 2 pi. So to get from 0 to 2 pi, the period is going to be pi. So we'll talk about that more in transformations, but just note that the period is not always 2 pi, but it does relate to sort of like how quickly and how big the x value has to be to go around the unit circle once, because when you go around it once and then you add again, as when we looked at the trig values, it doesn't matter. Once you get 2 pi, it just sort of resets, and that's why you can have this go along it. Once you've gone 2 pi, then it repeats itself the exact way. Just like sine, this also happens the other direction, and you can work these out for the negative values. So it's the same, but instead of going the positive, you're going to go negative, but you'll get the exact same results. And you can see the same shape here. And so the shape between here and here, so that's one period. And once again, with the period, the difference between one point and another point, x-intercepts, is going to be half the period length.